This is a demonstration of how to convert from grams of a substance, a compound, to the moles of a compound. And here is a possible question. How many moles are in 695 grams of H2O or water? Let's take a look at the given. The question tells us that there are 695 grams of water. And then we need to use a conversion factor. And we have to remember what unit goes on the bottom of the conversion factor. We place in the bottom of this conversion factor the units that we are trying to cancel out, the units we're trying to get rid of. In this case, we're trying to get rid of the word grams of water, because grams of water is given. And then we read the question. What are we looking for? Those are the units that we place on the top. And in this question it says, how many moles? The other way that the question could be phrased is to say convert from grams to moles. So if you start with grams, put the grams on the bottom, and since we're looking for moles, we're going to put moles on the top. And then we realize, this is something that you must realize, that this conversion factor is the relationship between grams and moles. That's called the molar mass. And so therefore, we need to calculate the molar mass of this substance, water. We do that this way. How many formula units of hydrogen? There are 2. How many formula units of oxygen? There is 1. And then we multiply each by their individual molar mass. The molar mass of hydrogen is 1 gram per mole. Remember, for our class, we are rounding to the singles digit. For oxygen, there are 16 grams per mole. And then we multiply that across. And then we see that the molar mass of water is that 18 grams of water is 1 mole of water. And remember, you can also write it this way. 1 mole of water is 18 grams of water. And now we take this information in this form, because it's this form that has grams on the bottom, and we put it into the conversion factor. 18 grams is 1 mole. Before we continue our calculation, we realize that grams cancel out, and now we're left with moles of water. I actually like to write the units already before I even use a calculator, so that I don't forget to write the units, because this numerical answer will be in moles of water. And now it's just a matter of using your calculator to take 695 multiplied by 1 and then divide that by 18. And the answer is 38.6 moles of water. And just one more very small thing. Why did I report a 3-digit answer? Well, that's because there is a 3-digit question. And now that you know how to do that, you might want to take a look at some other sample problems and then be able to use that new skill to solve the worksheet that's assigned. To find out how to convert from moles to grams. This is a good example problem. How many grams is 4.65 moles of K2CO3? Let's stop calling that K2CO3. This is a good time to review how to name compounds like this. And this is certainly an ionic compound. And this substance is called potassium carbonate. So now we can just say potassium carbonate. All right, now that we know that, we write the given 4.65 moles of potassium carbonate. And the units that we place in the conversion depend on what we're trying to cancel out. In this case, we're trying to cancel out moles. And so that's why we put moles of potassium carbonate on the bottom of the conversion. And on the top of the conversion, we write down grams because the question says how many grams. It could also be phrased as convert from moles to grams, and so that's why grams goes on the top of the conversion. You have to realize something. You have to realize that this conversion factor is the relationship between grams and moles. This is the molar mass. And so we have to calculate the molar mass of potassium carbonate. We do that by counting formula units first. There are 2 formula units of potassium, 1 formula unit of carbon, and 3 formula units of oxygen. Multiply each by their individual molar masses, which you can find on the periodic table. Potassium is 39 grams per mole. And since there are 2 formula units, that's 2 times 39 gives us 78 grams per mole. There's only 1 formula unit of carbon, gives us a contribution of 12 grams per mole. And there are 3 formula units of oxygen, gives us 48 grams per mole. And if you add all that together, 78 plus 12 plus 48, you have a total of 138 grams of potassium carbonate in 1 mole of potassium carbonate. And in this form, or format of the molar mass, we already have grams on the top and moles on the bottom. So it is just simply a matter of inserting that number, those numbers, into the conversion factor, because 138 grams is 1 mole. So if we do that, we see that now we can cancel out moles, because that was, remember, the primary reason why we had moles on the bottom of this conversion, so that we can cancel moles out, and we're left with grams. And as I mentioned earlier, I like writing the units already. If my answer will be written over here, I like writing the units already. Grams of K2CO3, of grams of potassium carbonate. And so now it's just a matter of using a calculator. 4.65 multiplied by 138, then divided by 1, gives us an answer of 642 grams of potassium carbonate. So in fact, 4.65 moles of potassium carbonate is 642 grams of potassium carbonate. And that's how to convert from moles to grams. That's exactly what we were able to do here. We were able to take this unit, moles, and convert that amount to grams. And now you can use all these skills to solve the worksheet.